Okay, and so I'm going to pick up from where I left off, which was it made a successful prediction. However, we're getting a new error on the end here, and I believe I removed these print statements. So if I reload, then they're still there. Perhaps I did not rebuild. Style issue, hooks 960. Okay, so the problem that we're seeing here is that we can't actually do the prediction in the standard way. Now we were able to do this when things were not remote, but now that things are remote, it seems to be upset. So what we have here is a standard check. Let's first modify this error to actually print the ID so that we can see which tensor it is that we're talking about. So, although I suspect it's going to be these tensors that it's printing out because, no? Interesting. Yeah, let's print a little more into the error. So this error is in 510 on workers.py. So let's rebuild. So the idea here is that we should be able to see which tensor it is so that we can kind of better introspect what's going on inside of that particular tensor. Nine. So on the remote, so remote.id is 1. What's surprising to me interesting. So normally so which tensor is this? I suspect it's going to be model.weight. Did anything? Nope. Not that one either. Wonder if it actually even exists. Is it the one getting created? That could be. Remote.objects, so let's print it out here. Okay, so here's all the tensors that already exist. Create the error. Here are the tensors that exist now. Let's go ahead and put it up here. Okay, looks like here we have just one tensor. Oh no, 3 tensors. So one of them is the weights, one of them is the input data, and the output data. Now we have weights, input data, output data. Interesting. Got something without locations. Which one is this 554 business? Remote.objects 554. Okay, so that's the output prediction, it looks like. So we can check it's the right dimensionality to be the output prediction. So the output prediction is okay, so the command is getting executed to run the model. The new tensor is getting allocated. However, the new tensor is being allocated with isPointer set to true when it should be set to false. Now the question is, why is that happening? I assume that isPointer should be set to false. But one good way that we can double check that is let's reboot this, hold on. Basically what I'm going to try to do oh, it's already been sent. Figured it would need to be transposed. Perfect. Okay, so now if we send this across the network, we'll do it the old-fashioned way, just as a simple tensor operation. Ah, we get the same error. Now, isn't that fascinating? Looks like now we just have a genuine error. Wow, we're getting this error all over the place. Does the original MVC using virtual worker still work? Yep. Yep. Okay, well all this still seems to work. What about with variables? Huh. So what I'm going to try to do here is basically just run tests that I've done before. To see if perhaps something that's been merged lately actually broke this. Okay. Okay, float tensor seems to work fine. Let's try it with variables. variables are broken. Ruh-roh. Interesting. Variables are broken. It's very surprising to me that these tests, however, are passing, because I'm pretty sure we have a test for sending two variables and then adding them up. So let's check down into these unit tests and see what is going on. Okay. Yep, here we go. Ah, requires grad equals true. Let's just try changing that. That is very surprising. Okay, clean slate. Let's run this test that is supposedly passing. Now, why would this be passing? Doesn't make sense to me. Nope, doesn't make sense to me. Makes utterly no sense. Let's see. Obviously something here is different. Okay, I import torch in as an in. Ah, it does have something to do with the imports. Oh. Okay, so let's try these imports instead. We'll comment out as many of these as possible. Hit refresh. And then go over. Still doesn't want to work. Why would that be? Huh. Maybe it's not the imports. Maybe it's this whole hook for both equals false business. Okay, well, just for the sake of argument, wow, gotta get to the bottom of this. This is curious. What is the difference between you and you? Oh, I forgot to do local.add worker. That's what it is. Yep, that's gonna be it. That was it. Wow. And that's going to work right out of the box. Cool. Okay, let's try this again. So, my bad on forgetting to add the worker. I should have done that. Should probably add some sort of flag. weights.send. I'm going to redo this. I kind of want to try the good old-fashioned way again. Model.weights.send remote dot there we go. Ooh, got a new error. Okay, so it looks like add got an invalid combination of arguments. Got a string, but expected a float or a variable. That to me says the string was probably a JSON object. String was probably a JSON object. That would make a lot of sense to me. Cool. Let's figure it out. Oh, we still have the bias. Okay, now let's try it. It worked! Just forgot to send the bias as well. Cool. Okay, well, it's not learning anything, but it is at least performing the operations, and that is pretty cool. I wonder why it's not learning anything. This learning rate is constant. That's kind of weird. Let's just run the whole thing clean, see how we do. Okay, still not learning, but if I don't send anything anywhere, it learns. Okay, so this is inhibiting learning somehow. I'm not totally sure how. I'm going to guess that it has something to do with the optimizer. Now, one way I can check to see if it has something to do with the optimizer is see if gradients are actually getting backpropagated, and I'm pretty sure they are because I've worked with them in the past. So if I go model.weight.get, ooh. Okay, some kind of error. Let's check this out. Oh, it's not the same. Self.type. That might not be parameterized correctly. Okay, so let's say 696 in hooks. let's just try a 0. I don't know what's going to happen. That's fascinating. Oh, I didn't build it. That's why. Ooh. Failed. One of our tests failed. Int object has no attribute is sparse. Hooks 696. Uh oh. Whatever we did broke it. Okay. What is old set supposed to do? I think this is supposed to be type self. I could be totally wrong on this. What is register object supposed to be? So what this is doing is it's reinitializing the type, but I'm just not completely sure how. Okay, well those tests pass, that's something. Okay, so parameters do not have this, right? So this is something that's on PyTorch tensors, which means that we are passing a parameter in somewhere that it thinks that it should be receiving a tensor. That is a little bit strange. So we're having trouble deserializing the tensor. Hooks.py 696 is still the focal point of our issue. I think that this is probably supposed to be best guess. I think this was probably left out. Let's try it again. Boom. That's what it was. Cool. So now model.weight.data.grad. Whoop. Cool, so it is getting a gradient. Alright, so this means, let's do, oh sorry, quick. There we go. Okay, so we're getting pretty close. The part that we're still missing is gradient descent is not working, but we are getting gradients. wonder if ZeroGrad works. Wow, it does. Wonder if it works before we get it. Like, does ZeroGrad work remotely? Nope. Okay, so this does not work remotely. Going to have to figure that one out. I mean, all ZeroGrad does is iterate through parameters and multiply all of them by 0 if they have gradients. So it's really surprising to me that that it's not supported. But for now, let's just first start by replacing this optimizer with model.weight minus equals model.grad times. Oh, let's do that. Oh, dot data weight dot grad. They're on separate machines right now. Ooh. String object has no attribute I sub. That's surprising. Okay, so prediction is working fine. Backpropagation is working fine. What's unclear so model.weight.data exists. Model.weight.grad equals none. Why would that equal none? Ah, so before we sent it away, it equals none. And if a gradient gets computed on the other end, that doesn't necessarily mean that we would have an attachment to it. What that means is that gradients need to be initialized over here, or we need some other way to override gradients going over there. So basically what's happened is we sent our weights away, and then, surprise, surprise, the Python object on our client doesn't have a gradient, meaning it doesn't have a Python object here representing the gradient, but one ends up getting created on the other side. So the weird thing is that that means that we somehow need to know about that tensor, even though we don't have a pointer to it, which is very strange. And the reason that we need to know about that gradient is that without it, wow, fancy. But I know, funny enough, what would probably fix this would be doing this first. Let's just do this over here first, guys. Not get ahead of ourselves. So we're going to do a full backpropagation. This just generates grad objects. And then, later on, we send everything over. Okay, going to take a quick break. Be right back. Okay, and I'm back. So let's see. Now we're getting the error that we had before when we didn't properly inform the worker. Let's just reload it and get things fresh. That is really surprising. Why are we not able to send the weight? Ah, previously it did not have a gradient, but now that it does, we have a new error. It's probably going to be something super similar to what we saw before. .510 in workers. So mile points here is actually redundant. Well, so if the object is a pointer, which in this case shouldn't be true yet, I think we might want to just skip this. What is var to pointer? It's in hooks 978. Oh, it calls it on the gradient. Okay, so it does it recursively. So it registers gradients before it registers normal objects. Now why would the gradient already have been called? This is send. Ah, so register object is likely to have already registered it recursively, which means this, I think, oops, go back here. I believe this is redundant. 977. So what we're going to do is we're going to comment it out for now. I'm going to see if any of the unit tests fail when I do that. Well, that's a good sign. Okay, that is a bit more promising. And if I go model.weight.grad, funny enough, I can see that. Why can I see that? Does nothing get sent to be remotely? To be remote? Ah. So with this, the gradient does not get sent. Fascinating. So we do need this. Actually, let's double check that the gradient doesn't actually get sent, because it could be something sketchier is happening under the hood. So this is the first pass, and we have model.weight.grad.id. So this is the ID. So now we send all of it over there. Cool, and now it's sent. On remote.objects 449. Ooh, it does not get sent. Whoops. That's not good. So apparently we might actually need this. When was send, yeah, uncommented for now. When was send diff? Hook var send. So this is where the variable should send. And here is the send object command. And it sends self, and it converts this into a pointer. This does not seem to actually be working. So let's check worker, send object. Prepare to send object. Serialization. Okay, so somewhere in the serialization perhaps is where it's breaking. Let's print the object JSON here and see whether or not it is actually serializing the gradient of this model weight. Okay, moment of truth. Grad is a variable. Yep, so the gradient has been initialized. It does send it, and has an ID 797. And now if we check remote objects, it does not, however, get deserialized. The only thing I see here is the input data, the target data, and the parameter for these weights. So The real tragedy is that receive object is not deserializing this correctly, which means variable possibly hooks. Go variable deserialization. Let's get rid of this print statement since we know that it's working, and instead hop down to this deserialization method. So what I'm going to do in this deserialization method is attempt to first print the object message. Actually, let's start with that, because that's what deserialization is actually receiving. We'll deal with that style error in a minute. It should be exactly the same as what these are sending, so it should look largely the same. Yep. Yep. And a print error. Did not expect that. Oh, no, that's the error that we put back. No big deal. Okay, so this one okay, here we go. So it does have grad. So there is a gradient. Let's try it again. Ah. Reload the notebook. Rerun ourselves. Good. Okay, now we don't see there's a gradient here because none of these had gradients on them. Okay, this one does see that there is a gradient, so that's good. And object message, grad. Okay, so in this case, let's stop printing this object message. Well, tough call. Just want to get some new lines around it so that it's easy to see. Sometimes it gets tough to see what's going on. Here we go. And while we run it, no gradient, and there is a gradient, and this is the gradient. Man, looks like it's parsing the data correctly. Okay. Let's see how it does handling the actual grad object itself. Does the object get created? Looks like it does. Indeed, it does. Okay, so what we're seeing here is that the gradient has been initialized. Let's comment this out again. 93. I just want to see what happens. Because previously what we were seeing was that the gradient was getting created, but yeah, I think we're fine. Okay, and the gradient should have an ID of this. So still not there. Why is that not getting registered? Okay, so the next is HandleRegister. Let's check out HandleRegister. If it exists already, remove it, then call a register object. And here we go. Let's go ahead and print the ID. Just so we can see it getting registered. Hopefully we'll see this register object function getting called on the gradient, and we can see why it's not actually getting registered. Key error ID. Okay. Try this one more time. Few objects got registered there. Tends to be a pretty popular method, as you can see. Some optimization we should probably look into. Whoa, that is a lot of object registration right there. That is hilarious. And just printing it registers a ton of objects. What a nightmare. Okay, well. Goodness, this is intense. I can hear the ducks outside making a lot of noise. They tend to chase each other around this time of night. Okay, so that was the one. Still only have 3 objects. This is nuts. How am I supposed to know what's going on? Things are getting registered like 1,000 times. Okay. So this is the gradient. This is the ID. Oh my goodness. This register object gets called literally dozens of times. And yet, it gets deleted at some point. I wonder why that is. Okay. Why does that get called so many times? I feel like that might actually be a different issue than this one. Let me check one thing real quick. Be right back. Okay, so we just learned two things. first and foremost, we are registering objects way more than we should. I believe this also has somewhat to do with the printing, so PyTorch actually creates a surprising number of objects in the printing process. Let's see. Remote.objects. Let's try this out for size. See if this has any gradients. That's that. Ah, look, the gradient is actually just attached. Well, isn't that fascinating? So the gradient is actually there. It's just not registered into underscore objects. Now that is an interesting problem. So if you're not familiar with how this interface works, basically this remote has a dictionary called underscore objects, and what happens is you send it an object and it throws the object into underscore objects. In this particular case, it has correctly deserialized the gradient and given it a pointer and allocated it as a .grad on top of underscore objects. But the weird thing is that it is not registered the pointer, which is probably because we commented it out this thing down here because it was giving us an error, which makes me think that Federated pointer was actually being called. Wait, where was it being called? We saw where it was being called. Oh man, I saw it. No, it's being called on send. Let's put this back and just try to solve for this error instead. So it's already been set. Workers.py 510. So this to me makes me think that Federated pointer has actually already been called on this object. So let's just print out when we're calling Federated pointer. .id. Wish us luck on this one. All right, here we go. Makes sense. Huh. Federated pointer is only called once. And not, oh. Variable object has no attribute ID. Okay, so it does get called on the gradient. But that gradient has yet to be registered. Try that on for size. Interestingly, neither of these are actually the gradient in the variable ID. Okay, so before we do anything else, let's go back to our old standard of not doing a linear model, instead doing model equals in dot torch dot float tensor. Let's do torch dot zeros. Variable requires grad equals true. Instead of so model no longer has weight. Data send model dot send. Well, isn't that interesting? So basically, we do not seem to have functioning support for sending a variable that already has a gradient attached to it. That seems to be broken. And I'm not entirely sure why. So if I go over here and don't run this, it works fine. Okay. So we have a bug that we need to fix. So actually what I'm going to do in this particular case is go over to PySift, and I'm going to go ahead and open up an issue and show how to duplicate this result. So data.send, target.send, actually model.send. Oh, we need forward prop to actually work, didn't we? Okay, here we go. Model.send remote and an error. Okay, so this is the code we need to reproduce. Okay, so in this particular case, we're looking at a bug. Yes. I'm not gonna do a user story this time. Let's see, there's a way to make this look like code. Perfect. Following code. Oh. So I expect that when I call model.send remote, that it will send the variable to the remote virtual worker. However, it errors out and does not variable. Well, yeah. The following stack trace. I don't know how well the stack trace will print. It should be pretty easy to. That doesn't look too bad. Maybe if I put that inside of code, it would look a little nicer. Oh, that looks way nicer. Maybe I can put the rest of it in there too. Oh yeah, that's great. Very good. Okay. Oh, already sort of did that. Cool. And I will go ahead and let Jason, JVman, and Bobby know about it. Actually, really, Jason, he's the one who needs to know about it just because he helped build this interface. And we will likely work together on trying to fix it. So, yep, this was the error. Since it's getting pretty late, I'm going to go ahead and sign off. But we will address this bug tomorrow and then be able to return to work on the federated learning interface. Hope you have enjoyed this quick chat. Yeah, I'll see you tomorrow.